In this video, we are going to solve this question. With the help of this question, we are going to learn the three different things. First thing is, if the distribution is given to us, we need to verify whether this is a density function. That is the first part. So we need to verify is this function is a density function. Secondly, अगर आपके पास कोई function given है that is a density function, how we can calculate the probability in this case. And lastly, फंक्शन से हमें क्यूमुलेटिव फंक्शन कैसे कैलकुलेट करते हैं इन द केस ऑफ कॉन्टिन्यूस रैंडम वेरिएबल एंड उसी CDF से हम कैसे इवेल्युएट कर सकते हैं प्रोबेबिलिटी. सो बेसिकली इसी क्वेश्चन की हेल्प से हम कॉन्टिन्यूस रैंडम वेरिएबल के हर एक पोर्शन को टच करेंगे. एज पर दिस क्वेश्चन, suppose that error in the reaction temperature for a laboratory experiment is a continuous random variable having this probability distribution function. First, we need to verify is this function is a density function. Density function में क्या conditions होती हैं? We have two conditions here. The first condition is f of x is greater than equal to 0. Second condition is integration from minus infinity to infinity f of x is equal to 1. So let's verify whether this is true for this function or not. So before verification, let's understand how this function is written. So generally range होती है that is from minus infinity to infinity. Now according to this function, minus 1 to 2. Let's suppose this is minus 1 and this is 2. In this range, the function is defined as the x square by 3. Except that the function value is 0. Now think, क्या ये function हर एक x के लिए greater than equal to 0 है? Yes, या तो वो 0 है और this term is also greater than 0 because x square term है that is always greater than equal to 0. So we can write obviously f of x is greater than equal to 0. Now verify the second condition. According to the second condition, we need to take the integration of the function from minus infinity to infinity with respect to x. ये function piecewise defined है, so we can split this integration according to this one, that is from minus infinity to minus 1 plus minus 1 to 2 plus 2 to infinity. What is the function in this case? That is 0. Here that is x square by 3. Here the function value is 0. So integration of 0 is 0. Integration of 0 here is also 0. It means we just need to calculate this integration. So this is equal to 0 plus integration of x square is x cube by 3. And this 1 by 3 is as it is. Limits are from minus 1 to 2 and here it is a 0. Simplify this. This is equal to 1 by 9 x cube. Substitute upper limit. 2 cube is 8 minus 1 cube that is minus 1. This is equal to 9 by 9 and that is equal to 1. So yes, integration from minus infinity to infinity of this distribution is equal to 1. So we can say that f of x is a density function. Now the second part is we need to find the probability when x lies between 0 to 1. So यहाँ पे हमें probability निकालनी है with the help of this density function. वो कैसे निकालेंगे? सबसे पहले ये चेक करो, यहाँ पे पॉइंट्स एक साइड पे इंक्लूडेड है, सेकंड साइड पे एक्सक्लूडेड है, तो ये हमारी प्रोबेबिलिटी पे इम्पैक्ट नहीं करेगा बिकॉज प्रोबेबिलिटी एक पॉइंट पे 0 होगी एज x इज अ कॉन्टिन्यूस वेरिएबल. या तो आप इक्वालिटी लिखो या ना लिखो, स्टिल द प्रोबेबिलिटी आंसर इज द सेम. So that is calculated as integration. Lower limit we have 0, upper limit is a 1 of the function fx dx. अब 0 से लेके 1 तक फंक्शन की वैल्यू क्या है? यहाँ पे 0 है, यहाँ पे 1 है, सो दिस इज द रेंज. अब इस रेंज पे भी तो सेम फंक्शन है. इट मीन्स द फंक्शन वैल्यू इन दिस केस इज x square by 3. So simply take the integration of x square by 3 and then substitute the upper limit as a 1 and lower limit as a 0. So integration of this is x cube by 9. 0 to 1 are the limits. Upper limit 1 by 9 minus lower limit 0. That is equal to 1 by 9. So in this case the probability is equal to 1 by 9. Part is find capital F of x. Capital Fx क्या होता है? That is the cumulative distribution function. Small fx is probability density function. So यहाँ पे हमें cumulative distribution function निकालना है with the help of this PDF, and after that we need to evaluate the probability when x lies between 0 to 1 with the help of CDF. So सबसे पहले हम CDF कैलकुलेट करते हैं, then हम ये probability निकालेंगे. As per this function, हमारा फंक्शन कहाँ से कहाँ तक डिफाइंड है? That is from minus infinity to minus 1, it is 0. From minus 1 to 2, function value is x square by 3. From 2 to infinity, function is 0. It means we have 3 different intervals for the x. कौन कौन से intervals मिले हैं? That is from minus infinity to minus 1, then minus 1 to 2, then 2 to infinity. So हमें इन तीनों intervals के corresponding functions निकालने हैं for the CDF. How to calculate this? So when we consider this interval minus infinity to minus 1, तो CDF आप कैसे कैलकुलेट करते हो? F of x is equal to probability when x is less than is equal to x, or we can say from minus infinity to x, f of x dx. So according to this, we have f of x is equal to minus infinity to x fx dx. अब x कहाँ से कहाँ तक लाई कर रहे हैं? फ्रॉम माइनस इन्फिनिटी टू माइनस 1. इस रेंज में फंक्शन की वैल्यू क्या है? दैट इज 0. So we can write minus infinity to x 0 d of x. Integration of 0 is 0. It means this functional value we are getting here as a 0. Now take the second range when x lies between minus 1 to 2. Capital F of x. सबसे पहले हमें यही फॉर्मूला लिखना है, that is minus infinity to x fx dx. अब x कहाँ से कहाँ तक है? माइनस 1 to 2. इसका मतलब क्या है? हमें इंटीग्रेशन लेनी है सभी फंक्शंस की फ्रॉम माइनस इन्फिनिटी टू x, और x कहाँ तक है? मैक्सिमम 2. इट मीन्स वी नीड टू टेक द इंटीग्रेशन ऑफ द फंक्शन of 0 from minus infinity to minus 1 and integration of x square by 3 from minus 1 to 2. But इसको हम कैसे लिखते हैं? We write minus infinity to minus 1 f of x dx plus minus 1 to x. Never write 2 here because हमें cumulative distribution function निकालना है. And x कहाँ से कहाँ लाई कर रहा है? From minus 1 to 2. We cannot fix x as a 2. एक रेंज में है, तो अगर यहाँ पे 2 पुट करोगे that will be the value of f2. बट हमें आंसर यहाँ पे x की फॉर्म में मिलेगा because the function is in form of variable. So always keep x here, not this 2. f of x dx. Now function here it is 0 plus integration from minus 1 to x. In this case the function is x square by 3. This is equal to 0 and here it is x cube by 9. Substitute upper limit and lower limit. What this gives us? This is equal to x cube by 9 minus minus 1 by 9, that is x cube by 9 plus 1 by 9. It means in this case CDF is x cube plus 1 by 9. Now taking the third case, when x lies between 0 to infinity, cumulative distribution function is defined as integration from minus infinity to x fx dx. यहाँ पे x की रेंज हम जो कंसिडर कर रहे हैं दैट इज फ्रॉम 2 टू इन्फिनिटी, कोई भी वैल्यू हो सकती है यहाँ तक. इट मीन्स हमें फंक्शन की इंटीग्रेशन लेनी है फ्रॉम माइनस इन्फिनिटी टू -1 प्लस इंटीग्रेशन ऑफ फंक्शन फ्रॉम -1 to 2 plus integration of a function from 2 to x rather than infinity. So we write here as minus infinity to -1 function is 0 plus integration from -1 to 2 the function is x square by 3 plus integration from 2 to x and the function in this case is 0. This is equal to 0 and the value of this one is 1. We have already calculated in the first part, plus 0. So this is equal to 1. So here the functional value we are getting as a 1 in a CDF. So this is how we are finding the CDF from the given PDF. Now second part we have evaluate probability when the random variable values lies between 0 to 1. Here we can use a one formula, that is probability when x lies between a to b, that is calculated by cumulative function at b minus cumulative function at a. So ये concept आप यहाँ पे apply कर सकते हो, that is f of 1 minus f of 0. f of 1 क्या है? ये cumulative distribution function है. 1 कहाँ पे लाई करता है? in this range. तो x की वैल्यू आप यहाँ पे 1 सब्सटीट्यूट करो. सो 1 क्यूब प्लस 1 by 9 दैट इज 2 by 9 माइनस f of 0. 0 कहाँ पे लाई कर रहा है? दैट इज अगेन बिटवीन दिस रेंज. So put x is equal to 0 here. We have 1 by 9. That is equal to 1 by 9. So this value is equal to 1 by 9 and even we have previously calculated that its value is 1 by 9 with the help of PDF.